first thing, number one, the goal of number one was to make sure you knew that a computer or a calculator printout only gives you the standard deviation of the residuals. Okay, so this is just the standard deviation of the residuals. You want to get the standard deviation of the slope. It's a pain in B over T, the bot. So you do literally take this sample slope and put it over the T value over there. Okay, and that's how you came up with that. I actually kind of had to play around with this decimal to make it come out exactly what they had, because I had put more decimals in and then it came out to 2208. But when I just rounded it to 2 decimals, it came out to what they had. Okay, now, on this number 2, I wrote down what the formula is, B plus or minus T star times standard deviation, because you have to be able to get an interval by yourself with a formula without having the individual pieces of data. Now, so this formula right here is your key, and I want to remind you where that is located on the formula chart. If you look at the formula chart, it is right here in a generic form. So you've got to have your standard deviation, that's the sample slope, plus or minus your critical value, and you get that from inverse T of 1/tail, comma, degrees of freedom, okay? And then your standard deviation of the slope. All right. So you plug those things in, and that's how you get your answer there. Okay, number 3. I pretty much did expect that you would not really have been very familiar with the number 2 statement. Okay, I'm aware of that. But I went ahead and I put this problem in here because it was in an AP prep book, and I thought, well, gee, I haven't said anything about the test for the y-intercept. So since they have that in there, I guess I probably should at least enlighten you of that so that you've seen it, even though we do not run an official test for the y-intercept. Okay? So, first of all, statement number 1 is that the sample standard deviation is an estimate for this parameter. That's the sample standard the standard deviation of the all residuals. All residuals. Okay. But it's the statement number 2 that's a little different. It is this. It's saying that the t-value is the same for a slope test as it is for the t-statistic right here. This represents a y-intercept test. This is a Greek letter rho, lowercase p, which is a rho, R-H-O. And so that is actually a y-intercept test, of which we don't cover. We are not interested in that. Y-intercept is normally extrapolation, but let me show you what that looks like on a computer printout. Right here, look at this. This would be your t-value for your y-intercept, and of course, this is your t-value for your slope. I don't know if I've ever seen those come out to be the same number. Those are 2 separate tests. They don't have much to do with each other. They're separate values, separate tests, so those t-values are not typically the same. All right, so that is why statement number 2 is also false. Okay, statement number 3. The t-test for the slope of a regression line is always 2-sided. No, not necessarily. It can be 1-sided. It can be a greater than. It could be a less than. It could not even necessarily be a test for beta being 0. Beta equaling 0 is testing linear regression to see if there's a linear relationship. You could have a situation you go into a business and it says, we know there's a linear relationship, we have evidence of that, we've seen it over the years, we think the slope's about 6, but we have done some marketing and we wonder if the slope's now increased. So they could then, you could even have a situation where you test something against a slope of 6, or whatever it is that the business has historically had. Okay? So, therefore, 1 is the only true statement. All right. Number 4, you have to be able to come up with this. This is how you get the t-value from hand without the points that you can just plop it out of your calculator with. Now, I will tell you that you can find that on the formula chart. It's hidden. It's written as words, but it is there. Here's where it is. It's right up there above the interval. See, it says standardized test statistic. That is your t-score. It also could be your z-score. This one is written in generic words. The statistic, which for this is the sample slope, minus the parameter, which is the slope of the population, the hypothesized slope, over the standard deviation of this slope. Okay? We have seen this same formula for the first half of the year as a z-score, x minus the mean over the standard deviation. Or if it's a sampling distribution, standard deviation or square would have been. Okay. But anyway, so this is just really a generic statement about a t-value or a z-value in words. Okay, but it's there. I just might not recognize it without the symbols. Now, you were not asked on this section to find this p-value right here, but you need to know how to. We have done it before. You need to remember that if you are going to be finding this area in a tail, you are going to TCGF, which is the cumulative area from a t-score out to infinity, comma, degrees of freedom. So t to t, comma, degrees of freedom. And then if it's two-tail, you want to multiply that by 2. Okay, number 5 is a straight up do the interval by itself. Number 6 is a correct interpretation of the slope. A is too specific. It says that for every 1 increase in IQ, the aptitude score will increase by exactly that much. That's an approximation because all the different actuals are all around it. So C is the most correct. 7 is false for 2 reasons. Number 1, you could be testing something other than beta equals 0. I just mentioned that right here. You could be testing a business's claim that they historically have a slope of 6. Okay. And the other thing is you don't necessarily have a two-tail alternative. You could have a single greater than or less than. Okay, any questions on those parts? So, now the short answer. I do have to say that it was my bad that I left off the paragraph of data that goes with this problem. Even though I told you the sample size on Friday and I told it to you in a Remind 101 text, you kind of didn't have the information for this either. So, my bad, you kind of had to either make that assumption in order to do the problem, and you normally should not have to. If I had included the proper paragraph with this information, that data would have been there and you would know what your null and your alternative was, okay? So sorry about that. You normally shouldn't have to make an assumption there. Okay, as for the t-score and the p-value, which is from t to t, comma, degrees of freedom, but if you want it for two tails, you have to double that p-value. Okay. Number 9 is straightforward, 99% confidence interval, and then you're making the conclusion. Now, someone did point out that probably a full panic model without the A should have been done, and yeah, that's actually true. Okay, I gave that person a stamp. I probably should have done what the beta represented and the name of the interval. I have the I, the interval, and the conclusion. Okay. What is significant about that interval there? Negative 1.372 to 1.902. It contains 0. That's the critical thing that should jump out to you, which actually is asked in number 10. do you think the predictive linear relationship between height and pulse rate is appropriate? And not necessarily, because since 0 is in the interval, there could be no linear relationship between the data, and no, the pulse change could be 0. Okay, now, number 11 says, suppose that researchers were hoping to show that there was a positive linear relationship. Okay, that was another reason that I was like, oh, the original one up there with number 8 should have probably been two-tailed, because that now they're saying, what happens if it's just this one tail beta greater than 0? Well, what happens, your t-value doesn't change, but what happens to your p-value if you go from 2 tails to just 1 tail? It's half. Your p-value then was just the 0.3236 as opposed to the total 0.6472. Questions there? Okay. Now, this number 12 was pretty straightforward. I'm not really going over any of this part. You can check the key there. However, I want to talk about number 15. Number 15 is important because it asks you to make a prediction for children at a height of 30, that are the age of 35 months. Okay? Well, that's an issue. I mean, sure, you can plug it into the linear equation. All right? But if we look at the original data, the age goes from 18 months to 28 months. And sure, maybe in the lifespan of the children, it's linear in this section. Okay? So it's fine to predict within that area. But the model of their heights could change after that time. You know, it could then, they hit the 2's growth spurt, and then that becomes, you know, exponential. Okay, so that could happen, and then you cannot predict, because out here at 35, it is not continuing a straight line. Woohoo! Yes. So I would have expected the vocabulary statement about extrapolation. Okay. Woohoo! Yes. I bought empty boxes in the Action Center. I don't know if it ever really could be a requirement. Okay, here we go. Now, on this page, the situation is that you were technically not asked on numbers 18 and 19 to make a statement about the interpretation of those standard deviations, but you need to be able to do that. So you might want to make sure that you have studied and taken a look at these statements here, because that's something that you're going to be expected to be able to do and write out. Okay? So let's talk about that for a second. So for number 18, being about the standard deviation of the residuals, then that is the kind of typical distance that an actual is away from predicted. So in this case, in context, it would be that typical distance that the actual gallons in the pool is away from what it was predicted to be. And I had put 9.3, but it was in thousands, so it's really 9,300. Okay, and then number 19, standard deviation of the slope. Well, that's referencing that from sample to sample to sample, every sample is going to be a little off on the slope that gets calculated. Okay? But this standard deviation of slope gives you that indication of how much variability in the slope is acceptable or typical. So here it is. The slope of the relationship between the time and the gallons will typically vary about that much from sample to sample. Okay, and then number 20 was straightforward, is because of the p-value. Yes?
What is the layout of this test?
I would anticipate it being, and I don't have it for sure, like 15 multiple choice and 1 free response. That's what I have flown around my brain. Okay? All right. Now, let's look at this number 21. This one is a very critical problem. Let me talk to you about the actual AP exam format, because this was a particular problem on the AP. Thank you so much. Appreciate it. Okay, so your AP test that you'll take in May is going to have 90, the first 90 minutes is 40 multiple choice questions. The second 90 minutes is 6 free response. And of those 6 free response, the first 5 of them will take about 12 minutes each. They will be more straightforward, not so outside of the box, pretty much kind of factual stuff we've learned in class. Okay, now listen up. Problem number 6 is double the points, and it should take double the time. It'll take 25 to 30 minutes to complete the number 6 on the AP exam, because what it does is take things you have learned and arrange them and ask you to expand upon them in a new and different way than has been taught in any class. Okay, so this was a number 6 in like 2010, and I'll be honest with you, I think this is kind of an easy number 6. Okay, so we'll go through this one, but I'll show you kind of where they were wanting you to go above and beyond what you've already learned in class. Yes.
Would you advise us on keeping them nice and these?
Yes, and I'll talk to you about that too, but I think that would be a good idea to have a way to take time. But you have to be careful about, like just a regular watch. You can't have particular fancy stuff and no alarms and all that kind of stuff. But we'll talk about that later. All right, so here we go. Number 21 on this was first asking you to interpret slope. That's a straightforward question. For every 1 foot increase, house price is going to go about $165. Okay, part B is another straightforward question. This one was not really a big deal, not an extension. It's just an interpretation of the residual in context. That this particular house, with this particular square footage, has an actual price that's $49,000 above what its value was predicted to be for the house of that size. So, you needed, the components needed was the actual compared to the predicted for a house of that size. Those are the 3 things that you would need to have for full credit. Now, here is where the extensions start to happen. First of all, when you do this number 6, you are told in the problem the direction to go to get your information. So, for example, here in question C, it says, use the residuals. So they're wanting you to utilize the residuals that they gave you on the previous page to find out if there is how much greater the price for the house with a swimming pool would be on average than the house without a swimming pool for the same size. So what I did was I averaged the residuals. It was nice in the table that they organized all the pool houses together on top, and so I averaged that, and I got 18.625, which what that is saying is those houses on average are 18,625 above predicted. Okay? Now, all of these ones down below, this section below is a negative 8.824, so all of these ones without a pool are on average 8,824 below predicted. Now, to tell the difference to see how much greater the ones with a pool are than the ones without a pool, I subtracted and I got 27.45, so that's about 27,450 that I expect the ones with a pool to be above the ones without a pool. Okay? Now, then they decide that they wanted to make more homogeneous populations and have 2 separate sets of data. The linear regression with the pool, the linear regression without the pool. So see the red stars? That's 2 separate equations of the line. And so then they compare those slopes, and D, what do you see significant about that interval that should pop out to you? 0 is in there. So that's the thing that you hone in on, and then therefore you say, since 0 is in this interval, I have evidence that there could actually be no difference between the 2 slopes. Now, look at part E. Again, to use. And it says, use the regression model. So that's the equation for the houses with a swimming pool and the regression model for the ones without. So use those two red starred equations. Now the answer key I accidentally messed up when I subtracted. This is supposed to be a plus 0.006. So I subtracted the equations, kind of like you would do with a system of equations. So I subtracted that, and then I was thinking, okay, I need to plug a size in. I had some do any size. I had some just take the two equations and put a size and find the difference between them. That's also fine. Those are all fine. So I actually averaged all the sizes and got that. I think that's probably, you didn't have to, but it came out 29,190. And so, yeah, it was somewhere in the vicinity of the estimate that Part C gave me. Okay, that's it. So you can keep those keys now. And any other questions